Hi guys, we're going to be converting recurring decimals into fractions, but to do that we need to understand the recurring notation. So let's crack on and get the job done. 0.3 with a dot above it means 0.3333 and the 3's repeat. That's what the little dot over the 3 means. 0.26 with the dot just over the 6 means it's only the 6 that repeats. So it's 0.2 and then the 6 repeats. So it's a repeating or recurring 6, but just a single 2. However, in this example, we've got a dot over the 4 and the 6, and that does mean that both the 4 and the 6 repeats. So it's 0.46, 46, 46, etc. And finally, if you have a string of decimal figures that repeat, we only put a dot over the first and the last figure of the string. So in this example, it doesn't mean that just the 2 and the 5 repeat. It means everything from the 2 to the 5 repeats. So that would include the 8 as well. So it means the string 2, 8 and 5 all repeat. So it's 285, 285, 285. All digits between the dots recur or repeat. Now we need to understand the decimal notation. There's no doubt about that if we are to understand how to convert from a recurring decimal into a fraction. So 0.3 with a dot above. Let that equal A or some letter. I've chosen A. Let's go with A. A equals 0.3 with the dot above. So that means 0.3333 with the 3 repeating. And we multiply both sides by 10. So on the left-hand side, A becomes 10A. And the right-hand side, if we multiply it by 10, we end up with 3.333 repeating. And we multiply by 10 until we can see two decimal parts the same. Okay, and in fact, we can see two decimal parts that are the same. When we've got two decimal parts that are the same, we stop there and we use those two expressions. So 10A, which is 3.3333, and A, which is 0.3333, we're going to subtract one from the other. And the reason we do that is because when we subtract, because the decimal parts are the same, they will all disappear. They will cancel out. And so I will be left with 10A subtract A, which is 9A, and 3 subtract 0, which is 3. Now, if I've got 9A, in order to find out what 1A is, I need to divide by 9, cancel down the fraction, and so 0.3 with a dot above it is 1/3. And you probably knew that, but here's showing you how to show that. Let's move on. Second example. Quickly run through this. It's very similar to the first, as you can see. What was the first step? Can you remember? Let A equal the recurring decimal. Let some letter. I've chosen A. Then we multiply by 10. A becomes 10A and 0.7 recurring becomes 7.7 recurring. I've now got two decimal parts the same. I'm going to use those two parts. So 10A subtract A, remember we take them away, and the reason we do that is because the decimal parts are going to cancel out. That string of decimals will cancel out with that string of decimals, So on the left hand side, I've got 10a, subtract a, that's 9a. On the right hand side, I've got 7 subtract 0, that's just 7. From 9a, I want 1a, so I divide by 9, and that is the fractional equivalent to 0.7 recurring. 0.7 recurring is 7/9. Example 3, we've got 2 digits repeating. A equals 0.232323. We multiply by 10 again. So we have 10a, and on the right hand side we've got 2.323232. Now note, the decimal parts are not the same. In the first decimal part we've got 232323. In the second decimal part we've got 323232. So we just multiply by 10 again. 10a becomes 100a, and 2.323232 becomes 23.232323. Remember, we're looking for 2 decimal parts the same. We found them. A has got 232323, and 100a has got 232323 in its decimal. They're the same. Those are the 2 parts we're going to use. So 100a, take away 1a, we're going to see those decimal parts are going to disappear. 100a take away a is 99a, and on the right hand side we've got 23 take away 0, which is 23. To get from 99a to 1a, I divide both sides by 99. That fraction doesn't cancel down because 23 is prime, and therefore 0.23 recurring is 23 divided by 99. Now, if you think you understand the steps, why don't you get a bit giddy, pause the video and try this example, and then I will catch you up when you press play again. The first step, let a equal the recurring decimal. We times by 10. When we do that, can we see 2 decimal parts the same? No, because for a we've got 0.7878, and for 10a we've got 0.8787. So we multiply by 10 again. 10a becomes 100a, and 7.878787 becomes 78.787878. Can you see 2 decimal parts the same? I think we can. Those are the 2 parts we're going to use, 100a and a. So it's 100a, take away a, because when we subtract, those decimal parts will just cancel out. 100a take away a is 99a, 78 take away 0 is 78, so a is 78 divided by 99, and that does cancel down, and there's our answer, 26/33. This next example has changed slightly. Again, if you think you can cope with this, pause the video and crack on. A equals 0.42 with a dot over the 2. It's only the 2 that repeats. We multiply by 10. 10a equals 4.2 recurring. The decimal parts aren't the same, so we multiply by 10 again. 100a equals 42.22222. I can see 2 decimal parts, and I'm sure you can too. 10a and 100a. Those are the 2 parts I'm going to use. 100a, take away 10a. It's going to see those decimal parts cancel out. 100A take away 10A is 90A. 42 take away 4 is 38. Let's divide both sides by 90. Let's do some cancelling down, and that's our final answer. Here's our final example, and you know what? I'm sure you can do this. Go on, press pause, have a go. Let's see if we got this right then. A is 0.56, it's just the 6 that repeats. We multiply by 10. 10A equals 5.6, and it's a 6 that repeats, but the decimal parts are not the same. So we multiply by 10 again. 100A equals 56.666, the 6 repeats again. That's two decimal parts that are the same. Those are the two parts we're going to use. 100A take away 10A. And when we do the subtraction, those decimal parts just melt away and disappear. On the left hand side we get 90A, on the right hand side we get 56 take away 5, which is 51. We're going to divide both sides by 90, so A is 51 over 90. We get our cancelling down boots on, and our final answer is 17 divided by 30. Now let's put that all together in a recap. First of all, we need to understand the recurring decimal notation. So we need to understand what 2 dots over 2 digits means. Those 2 digits repeat, for example. We keep multiplying by 10 until the decimal parts are the same. So times by 10, no, the decimal parts are not the same, so we times by 10 again. I can see 2 decimal parts that are the same. Those are the 2 parts I'm going to use. What do we do then? We subtract the 2 sums which have the equal decimal parts. So that will be 100A take away A. The decimal bits disappear. We're left with 99A equals 23 in this case. And our final step is to then solve that little equation to find the missing letter. In this case, we divide both sides by 99, and our final answer is A is 23 divided by 99. And if there's anything about the video you haven't understood, just watch it back. And if you have, that's great, because that's the job done.